All right, today we are going to be measuring angles and arcs. Measuring angles and arcs. We're on page 706. And a central angle. Of a circle as a vertex on the center of the circle. And its sides are radii. So a picture of that would look like if we got a circle here and the center of this circle is point B, and then a radius and a second radius to points A and C, and we can say angle ABC is a central angle. ABC is a central angle. So now if we add one more radius here, call this point D. Angle CBD is also a central angle. And right now what we have is three angles inside of this circle. We got this first angle, angle 2 right here, and then we've got this bigger angle around the back, that's angle 3. And we're going to say that the sum of the central angles of a circle is 360 degrees. The sum of the measures of angle 1 plus angle 2 plus angle 3 must sum 360. And then on the bottom of page 706, there's an example we can do where we're going to find some angle measures. All right, if you're asked to find x, find the value of x. You're given a circle, and inside this circle, you've got a couple of angles. All right, and let's say that this top angle here is 130 degrees, and here's our x. All right, when we see this symbol in the corner of this angle, that means 90 degrees, right? So let's not forget about that angle. It's 90 degrees. So x is equal to 360 minus 130 minus 90. All right, it's just that simple. All right, so our x is equal to 140 degrees. In this next circle, all right, same concept. If one angle in here is 145 degrees, another angle is 165, and we need to find x. Well, our x is just equal to 360 minus 145 minus 165, and then it's just a calculator problem. $50 degrees. Everybody okay with that? All right, let's talk about an arc. An arc is a portion of a circle defined by endpoints. All right, so in this circle right here, this red portion, all right, that's an arc. We can call it, here's a little symbol for arc, just a little arc AC. Arc AC starts at point A, and it takes the shortest possible route to point C. There's another arc in this same picture. If I add a point to the back side of this circle, point D. Now if we started at A, but we didn't take the shortest route, we went the longer route through D and ended at point C, that's called arc ADC. All right, the first arc, arc AC. It's also known as a minor arc. It's less than 180 degrees. starts at point A, takes the shortest possible route to point C. When you're talking about the other arc in this circle, it's more than 180 degrees. It's called a major arc. Major arcs, those are always described with 3 points. Major arcs are always described with 3 points. The point that you're starting at, the point that you're going through on your way to the end point. All right, so if we start at A, we go through D, and we end at C, we describe that arc as ADC. If we're starting at A and we're going directly to C, and we're going less than 180 degrees, we use 2 letters, and it's called a minor arc. Now, the third arc you'll see today if we've got M, N, and O. All right, so we've got MO here. It's a chord, but it goes through the center. So that makes it a diameter. All right. So if the arc has endpoints that are also a diameter, then we got arc MO is equal to 180 degrees, and it's a semicircle. So minor arc, less than 180 degrees. Major arc, greater than 180 degrees. Needs 3 letters, 3 vertices as its description, 3 points as its description, and then an arc with endpoints on the diameter is a semicircle, and it equals 180 degrees. All right, so let's look at example 2 on page 707. And we got to identify each arc as major, minor, or semicircle. Then find its measure. All right, we've got G, point G, K is the center, point J, G to J is a diameter. We've got K and H. We've got a 122-degree angle. And then we've got point L down here. The measure of arc GH is equal to, all right, we're starting at G. We're going directly to H. The measure of an arc is equal to the measure of its corresponding central angle. So this angle GKH has endpoints on the circle at GH. So the measure of arc GH is 122 as well. All right, and that's a minor arc. If we had to find the measure of arc HJ, measure of arc HJ, that's starting at H. It's going directly to J. All right, so if G through K to J is a diameter, it's a straight line. It measures 180 degrees. This angle right here is 180. Which means this angle HKJ plus 122 equals the other 180 of this circle. So this arc HJ is going to be equal to 180 minus 122. .58 degrees. And that arc HJ is also a minor arc. So this in here is 58 degrees. And then if you were asked to find the measure of arc HJG, all right, that starts over here at H, goes down here through J, and ends up over here at G. Okay? So we got to add together the 58 and the 180. So 58 plus 180. .238 degrees. All right, and that's a major arc. All right, anybody have any questions? All right, the measure of an arc is the same as its corresponding central angle. So an arc, 122 degrees, because this angle was 122 degrees. Arc HJ is 58 degrees, because its central angle measured 58 degrees. If this diameter is a straight line and it measures 180, then this arc around the bottom of this circle, a semicircle, is 180 degrees. All the angles inside of a circle must sum 360. All of the arcs formed by those angles must sum 360. Okay? Any questions? All right, then your practice for today starts on page 710. and 1 to 3. Oh, I'm sorry, 1 through 5. And then over on the next page, 16 to 23. All right, we got 10 Alex topics this week.